we're looking at just reviewing fractions. And the first thing I want to start with is multiplying, because actually of all the operations, multiplying is the easiest. You don't have to worry about denominators. You just multiply straight across on multiplying. So this one would just be 3 times 5, which is 15. And what's 8 times 11? 88. That particular one, there's nothing I can really do to reduce it, so that's my final answer on that one. However, there are times where you have two numbers you're multiplying and you can reduce it. And you can actually do something I call pre-reduce it before you even go on. Look at this particular one, negative 2/3 times negative 9/4. First of all, it has two negatives, so what does that tell you? It's going to be a positive answer. Now, the next thing I want you to look at is at the diagonals. Notice, does 2 go into 4 at all? Yeah. So I can actually say 2 divided by 2 is 1, and 4 divided by 2 is 2. I can go ahead and pre-reduce it. The same can be true for the other diagonal. Does 3 go into 9? Yes. 3 times. 3 goes into 3 once.
By pre-reducing, you're making it easier to reduce in the end?
Yeah, you don't even have to reduce in the end. Yes.
Why don't you call it producing?
Producing? Yeah, that's a good one. I can do that. Coin a new phrase. Okay, 1 times 3 is 3, and 1 times 2 is 2. So that's your final answer in that one. Okay? Now, the third example of multiplying is when you actually have a mixed number to start with. On this one, we have 3 and 2/3. So what do I need to do first? Yep, we need to change it to an improper fraction. And in order to do that, I'm going to take 3 times 3 plus 2 is my first fraction over 3. And that's going to be times 4 times 1 plus 1 over 4. That's the same thing as saying 11/3 times 5/4. Look at my diagonals. Is there anything I can do to pre-reduce it? No, there isn't. So I'm just going to multiply straight across. This will be 55 over 12. All right? So dividing is really the same thing, but there is a problem. You got to do something before you even divide. What am I going to do? Do you guys remember? Yeah, I flip which one? The second one? Yep. So that becomes 10 over 1. Now, can I pre-reduce this one? Yeah, then you'll multiply it after that. So that's why I changed it to a multiple. So 5 goes into 10 twice. 5 goes into 5 once. So 4 times 2 is 8 over 1, or just 8. Now, someone in my last class asked me, do I need to pre-reduce? Well, you don't. You don't have to at all. So if I didn't pre-reduce this, this would have been 4 times 10, which is 40, over 5 times 1, which is 5. And then you would have just divided it out, and it would have been 8, right? So to be honest with you, it doesn't matter to me which way you do it. Whatever way is easier for you, you can do it that way. But just know that if you don't pre-reduce, you're going to have to probably reduce it in the end. So let's do the same thing now, looking at this next mixed number. We have 4 times 4 plus 3. 16 plus 3 is 19/4. So we have to change it to our improper fraction. Divided by 3/2. What's the next thing I'm going to do? Yep, second fraction. Yep, we're going to flip that one, so it'll be 2/3. Okay, now can I pre-reduce that at all? Yeah, I can. So this becomes a 1. This becomes a 2. So now I have 19/3. Oh, that's not right. It could be 19/6. 2 times 3 is 6. Before I go on, just a little bit of review from our first couple sections. How do I change this back to a mixed number? Yep, I'm going to divide it. So 6 goes into 19 how many times? 3 times. 3 times 6 is 18. I have 1 for remainder. Now if I look at this in clockwise fashion, this would be 3 and 1/6. Those two are the same, right? On the quiz that you'll be getting Wednesday, it's going to be no calculators, but it's multiple choice. So it may be that you need to take it back into mixed fraction form, or you may not have to. I think there's some of both. Okay? All right, let's go to the next page. Now we're going to talk about adding and subtracting. The first two are the easiest, and can you tell me why? They have the same denominator. So all I need to do is actually just look across the top. I have 3 plus 2, which is 5. And then, do I have 14 on the bottom? No, you actually don't add the denominators together. So it's just going to be 5/7. Okay? Now we're going to do the same thing with subtracting. 11 minus 5. 6 over 12. Can I reduce that? Yeah. It's the same as saying 1/2. Because I can divide both the top and the bottom by 6. All right. Now, looking at this one, they have a different denominator. So, the easiest way to deal with a different denominator is to multiply the one by the other. So this one's a 5, I'm going to multiply it by the 4. And if I multiply the bottom by a 4, I'm going to multiply the numerator by the 4. This one, I'm going to multiply it by a 5, because that's the other one. So this will be 4/20 plus 15/20, and that's going to be 19/20. Okay, that one wasn't too bad. However, this one's a little bit messier. There are 2 ways that I can do this. The first way would be the same thing I did above. I can multiply both top and bottom by 24 and not even have to worry about a least common multiple. Multiply this one by 15. Problem with that is you end up with a really big number. But that's okay. You can have, this is 360, 24 over 360 minus 7 times 15 is 70 plus 35 would be 105. And then this would be 81 over 360, and it's going to be negative. Can I reduce that? Yeah. They both are divisible by 9. So this would be negative 9/40. All right. The other way that you could do this is by finding the least common multiple. So I'm going to take a little chunk out of the screen over here and do that. So if I'm looking at 15, my prime factorization of 15 is 3 and 5, correct? If I take 24, my prime factorization of that is 2 times 12. Reduce that from 2 to 6 and 2 to 3. So 15 I can write as 3 times 5, and 24 I can write as 2 to the 3rd times 3. What would be my least common multiple in this case? Well, I'd have a 5 in there. What else would I have in there? A 3. And how many 2's would I have? Yep, 2 to the 3rd. So my least common multiple in this case is 120. Now, My question to you is, what is the 15 missing in order to get to the 120? What of my prime numbers, what am I missing that 24 has? 2 to the third, right? What is 2 to the third? Nope. 8. It's 8. So I know I'm going to have to multiply the 15 by 8 to get 120. What am I going to have to multiply the 24 by? I can look at my prime numbers. What is my 24 missing that 15 has? A 5. So I have to multiply that one by 5 to get 120. So going back to this, I'm going to multiply the 15 by 8 and the 24. Notice I'm missing a part of my 4 there. 24 by 5. So this will be 8 over 120 minus 35 over 120. Okay, so what's 8 minus 35? Negative 27 over 120. So if I were to reduce that, because they both are divisible by 3, it would be negative 9/40. So as you can see, you get the same answer with either method. If you don't want to deal with a large number, you can find the least common multiple, or you can just deal with a large number. Whichever way works the best for you guys, you do, okay? Any questions?